Hi guys, welcome to Learn Electronics Repair. As you know, I'm of the opinion that there's lots to be learned by looking at old, obsolete electronics. So here we have a 6-inch colour TV. This is obviously quite old. I'm guessing it's probably from the 1980s. That's just a guess. We have, well, some presets in there I can see. I don't know if there's supposed to be any control knobs on here. Maybe there should be and they're just all missing, but the controls seem to be in there. We have audio and video in, VCR TV, an external antenna, focus control. Looks like there should be something there, but it's missing. Okay, and this runs from 13.8 volts, battery or AC adapter. I'm not quite sure why we have two connections there. Maybe you can charge an external battery from the power supply, I don't know. Earphones, yeah. Quite what the difference between VCR and TV is, I'm not sure either. But the first thing I do notice, and maybe you can hear it, there's something rattling around inside this. So I'm not going to just plug this in first. I'm going to open this up and have a look to see what is rattling inside here. When we do power it up, I'll put it onto my bench power supply and we can see what current it's drawing. We can also set a current limit as well, actually. It doesn't specify particularly what the current is, but I don't know, a couple of amps maybe, something like that. We can put the limit on. So it's saying there's no user serviceable parts inside this. Let's find out, shall we? Looks like there's a couple of screws here. I don't see anything else particularly that holds us together, but let's remove those two first and let's have a look, see where that gets us. As a lot of you guys may know, this is the first time I've actually tackled a TV on here of any sort. I can't repair the modern flat screens in the workshop. I have an agreement with the owner of the shopping centre basically, which turns out, although he said it was to do with you're supposed to have offices on this for the shopping centre, it's more to do with the fact that somebody else at the bottom end of here was fixing TVs, so I don't mind. You need a lot of space for TV repair, you really do. So I've not got into this yet, and hopefully this doesn't come into his embargo on TV repair in the workshop. This top cover is obviously loose from the rest of it, separate from this back panel. Okay, just come off separately. Probably held with clips or something somewhere. See if this spudger will help. Yeah, that sounds a bit promising. Ah, and this fell out of it. Oh, this is just one of the two screws I loosened in the back of it actually. Yeah, so it seems to be clipped together. Actually, this may not be obsolete junk as such, or rather, it's probably useful for fixing other obsolete junk, because I think this would be very good for old games consoles, ones that basically connected to a TV. Probably handy. The ones which had modulators in them, UHF, because obviously that is analog video. Come off. Yeah, something happened, the back fell off it. And now, yes, we have it. Okay. Well, the first thing I notice is that somebody has disconnected and soldered the speaker wires, but put no insulation tape on. That's a good one, yeah. I don't know why they've done that. The antenna connector is also captive effectively, but it's also broke at this end, so I think we can just undo that screw. Yeah, that was that. And the speaker, well, it's soldered to the board basically. There's probably one connector put in here just to make it easy to work on, but I think for now I will just go with whatever the previous person did and I'll solder this. I believe I found what was rattling around inside it is just this. Seems to be a piece of hard plastic or something, or fossilized chewing gum. I'm not sure. That's what was rattling in there. And just looking at this, there's more wires here that have been cut and soldered back together again. Must be some reason for that. Let's see if we can identify any of the parts of this. So obviously this is the cathode ray tube. This is the picture tube. It appears to be intact, which is good. This is the focus adjustment, the high voltage wiring going to it, you can see. Okay. The board sitting on top, this appears to be the tuner basically. Okay. There's one more board down there which I can see. There's a board across the bottom and there's a board up this side. So we have effectively 3 circuit boards here. We have a chip, this NEC chip. Yeah, I'm not familiar with what that is. This board looks like the tuner board. The other good reason for that, I think this is the antenna connection at the top there. Yes, so we can say this is the tuner, this is the receiver, okay? The one across the top here, this is probably the radio receiver. This has AM, FM, VHF, UHF, VLVH, not quite sure exactly what that one is. But those are all on this board, so I suspect this is also part of the tuner, probably the radio tuner. Then, in that case, then the board down the bottom of here, this is obviously effectively the TV, if you like. I can see some components in there at rather strange angles, like this capacitor down in there, for example. Yeah. And then we have a board down this side here. Okay, so that's what we actually have in this. Right, I think before we start, we should have a quick lesson on TV, especially CRT TV. Okay, CRT TV for beginners. So we have a cathode ray tube. This is a vacuum tube. And without going really into the details of this, I'll explain how the monochrome TVs work and then a bit of information on how the colour ones work. So, cathode ray tube, actually rather like a diode, has a cathode. It has a heater, a heating element, also behind the cathode, okay? And then it has some, if you like, pieces of mesh, which are called grids, okay? I'll just draw 2 for now, I won't go exactly into this. This end of the cathode ray tube, this is the front, which you can see the picture on, okay? And this is covered in a phosphor. A phosphor is a material that glows when it is struck by electrons. With a CRT or cathode ray tube, the rays are electrons and they're coming from the cathode. So basically speaking, the cathode, when it is heated by the heater behind it, it's just a heating filament, it emits electrons, okay? This grid, this here, is like a wire mesh, so the electrons are attracted towards this, and the reason being, this has a high positive voltage on it, okay? And this is called the anode, just like in the diode. Cathode. Because the anode has a high positive voltage, the electrons emitted by the cathode come this way rapidly. But the anode is also made of mesh and it has holes in it. So a lot of the electrons actually go through, okay? We'll talk about this bit in a minute. They go through and the electrons come across here, and this end of the tube has a high voltage connector on. It's called the final anode. And it has on a monochrome cathode ray tube, maybe 8 kV to 11 kV, something like that, depending on the size of the screen. So the electrons come whizzing along here, through here, and they hit the phosphor in the middle. And they produce a white dot. So we now have a white dot on the screen. This grid actually allows you to limit the amount of electrons that are coming through onto the phosphor, and the way that you do it is by putting a negative voltage on it. By putting a negative voltage on here, you can effectively limit the amount of electrons that are going to come through, because they are repelled by the negative charge on this grid. Again, it's just a metal mesh. Because it controls the flow of electrons, it controls the brightness, okay? And this is called the control grid. This one, by the way, this anode is actually called the accelerating anode. That's what causes the electrons to speed up and come through. This is the final anode, as I mentioned. And there's actually more than one grids in here. Generally, there's another one. We can draw it here. And this is the focus grid. So this effectively tightens the beam, okay? So those are effectively what we have in a monochrome tube. Now, all this will do is put a dot in the middle of the screen, and you can control the brightness with the control grid. So if you put a varying signal in here, you get varying brightness. But that's not a lot of use for TV. So what we have around the neck of the CRT are coils. Okay, we have coils in effectively both directions, like so. And these coils are deflecting coils. Effectively, they go all around the CRT. I can show you on ours. That's these. We can see all the metal coils here, okay. So by putting a sawtooth waveform on here, we can actually deflect the beam either up or down, or left or right. And the reason we use a sawtooth waveform is this. Sawtooth is this shape, okay? So what the sawtooth will do, it will cause the beam to start at one side of the screen. For example, on the horizontal one, to scan across. And when it reaches the other end, which is this end of the slope, it suddenly goes back down to this voltage, and it suddenly flies back. It's called flyback, it comes back to here. So by putting a sawtooth waveform on the horizontal deflecting coils, we can cause a line, okay? So it's not a line backwards and forwards like that. It scans across and suddenly shoots back, scans across and suddenly shoots back. So the line effectively is going in one direction and then starting again. Now, that isn't quite useful enough for a TV either. We need to have lots of lines to make up our picture, okay? So on the other coils, the vertically deflecting ones, we also put a sawtooth wave. But it is a much lower frequency, okay? This is not to scale. The frequency of the vertical deflecting one usually 50 Hertz, certainly in the UK and the EU, probably 60 Hertz in the US, no doubt. And that will do the same thing. It causes the beam to move up and down. So basically, the beam will start at the top of the screen, okay? And we will get one line scan. So these are nothing like the scale. This is at 50 Hertz. This one is at 16. Sorry, I remember this is like 30, 40 years ago. This one's at 15.625 kilohertz. I didn't even look that up. I was just going to do, and then I remembered it. Okay. So for UHF TV, what they call 625 line, the horizontal frequency is this. But if you divide 15625 by 50, you'll find you don't have 625. It's actually 312.5. It's half, yeah? So during one vertical scan, and this is called a frame scan. Let's use some terminology now. This is called the frame scan. And this is called the line scan, okay? So you'll actually find that during one frame, you get 312.5 lines, yeah? Say 312 lines. The other half is when the frame flies back from the bottom to the top again, yeah? And the reason we do this is because when this was designed to get 625 lines at 50 Hertz, the frequency we need, which is over 31 kilohertz, wasn't really easily achievable with the technology we had. So what it actually does is, in the first frame, it scans 312 lines, actually less a few due to the time it takes to fly back. And then it offsets the voltage slightly on the second frame scan. So these 312 lines, if you imagine the first ones are here, these are your line scans, yeah? So 312 times during this time, we get 312 lines on the screen, okay? After we get to the bottom of the screen, it flies back, starts at the top again, but it offsets slightly. So the next set of scan lines are here. Okay, in between. And that is called interlaced. And we even see this now with HDMI, for example, HDTV. You get 108T P and 108Ti. And the 108P is effectively 180 lines per frame, progressive, one after the other. And the other one is interlaced, one in between each other. So in this case, per frame, you have 1080 lines. In this case, per frame, you actually have 540 lines. And you do this interleaving or interlacing, yeah? It's to reduce the frequency, basically, that was required to create the picture. So that is how your TV creates a scan on the screen, okay? This scan of lines is called a raster. Now, that's not like a guy with dreadlocks, yeah, who likes reggae music. This raster is spelled like this, okay? Not the one spelled with the A at the end. Sounds the same, but it's a different word. So what do we have now? We have lines scanned across the screen, 312 of them. Then it comes back to the top and it scans 312 more, which are interleaved between the first ones and then back to the first set again. So although the scan rate is 50 Hertz, the frame rate is actually 25 Hertz. Okay? It takes 2 frames to give you the whole 625 lines of the image. So that's basically how a monochrome TV works. All we need to do now is vary the signal on the control grid to contain the video information, and we have a picture. We obviously need to synchronize all this together, so the circuitry needs to know when the picture starts, the first line, the second line, and so on. So we do this using synchronizing pulses. So basically between each line of data, imagine, so this is your line scan, okay? So between each line of data, you will have a synchronizing pulse, then you'll have your data for all the 312 lines. You'll have another synchronizing pulse, and then you have all your data again, okay? Synchronizing pulse, that is called a line sync. And after you've scanned all the way to the bottom, 312 lines, you'll get a frame sync. So you get another synchronizing pulse at the end of each frame. So effectively in here you've got a sync pulse, data, sync pulse, data, sync pulse, data. Obviously not the scale. So we get to the end and then we get a frame sync pulse. Okay, that says it's the end of the frame now. And then it starts again. That's how your black and white TV works. How do we get colour out of it? So to get colour out of it, we have 3 cathodes and we have 3 control grids, okay? So in the electron gun, now as it's called, this thing, we have the 3 cathodes with the heating elements behind them. They have to be hot to emit electrons, okay? And each one of these creates, imagine, so we have a control grid here for one, for the other one, the 3 control grids, red, green, blue, okay. We have the accelerating anode, and we have at the bottom end of the tube the final anode. And now on our screen, the phosphors are actually dots. So the dots basically are, well, either a grid like this effectively of dots, or in some cases vertical stripes like so. Okay, this was Sony Trinitron, by the way. Yeah, may have heard that. And we need to make sure that the electrons coming from each electron gun, each cathode, hit only the coloured dots that correspond to that colour. So these dots themselves will be phosphors, which glow red, green, blue. And the way we make the electron guns hit the correct dots is what's called a shadow mask. So imagine on the inside of your screen, we'll do the vertical, it's easier, we have phosphors like so. R, G, B, R, G, B. We then have a mesh, if you like, with holes in it, which correspond with the coloured dots. I'm not drawing this very well. And we have the electron guns, which are displaced from each other. So this one will always shine through effectively every 1, 2, 3rd hole and hit the red, phosphorus only. This one, I better use a different colour. I don't have a green pen, or I do have a red one somewhere, so these don't really correspond. But this electron gun will only shine through will only come through these holes and hit the green one. Okay, and the 3rd gun, the electrons will only go through the other holes and hit the blue. Okay, so that's how it actually does it. A very rubbish diagram, but I hope from my description you can actually understand how this works. This mesh is actually called a shadow mask. Okay, and this effectively also acts like an anode. It has a high positive voltage on, but because of the presence of the shadow mask, a lot of the electrons will hit the shadow mask and not hit the phosphor screen. So to get the same brightness effectively as this gave us, we need a much higher voltage on the HT circuit. So don't be surprised to hear that on the final anode here, final anode, the high voltage will be around about 25 kilovolts, 25,000 volts. This small TV will probably be less than that, but it's still going to be a very high voltage. I wouldn't be surprised if it was 18 kV or so. So the first thing this will tell us that these TVs, even the monochrome ones, contain some very high voltages. That means there are some hazards involved in repairing these things. So that's the first thing you need to know. If you're not comfortable with this, then I suggest you go find another video to watch. Okay? You can safely work on this equipment, you just have to know what you're doing. The rest of the TV circuitry, well, it's just the receiver that receives the data, if you like, to put on the screen, the picture. Now, with the colour TV, you don't send 3 pictures, one red, one green and one blue. You use a bit of trickery to do it. And the reason you do that is because when colour TV came out, it had to be compatible with the existing black and white TV. So in actual fact, the colour TV sends a high resolution monochrome picture that a black and white TV can also display. And it also sends on what's called a sub-carrier, another frequency. It sends colour information. And it doesn't actually send RGB, it sends some mathematical equivalents of those. I don't feel like going into them right now. If we have some problem with the colour on our set, we can look at them. But if you really want to know about it, look for the Mullard colour decoder. Google that. If you actually want to know how it does it. If we have some problems with that circuit, we'll have to look at it. What else can we learn in this lesson how TVs work? Well, we know we need a very high voltage to put on the final anode, 25,000 volts. How are we going to get it? Well, with the transformer. Okay, so we need a transformer with a primary and a very large secondary winding with lots of turns, and then we have to use what's called a voltage tripler to increase this again, times 3, and that goes to your final anode. For efficiency reasons, we want to drive this transformer at high frequencies. But look, we've already got a high frequency oscillator driving the coils on here, which effectively are also inductors. So what we actually do is we use the same transformer that is driving these coils, the line output transformer, and we add a separate secondary winding on the same transformer that generates the high voltage, the final anode voltage. So on our TV, basically we have a line oscillator. This is an oscillator generating 15.625 kilohertz, and that is driving this transformer. That's giving us a high voltage, and it's also giving us the deflection, the line scan. Going to the scan, going to the high voltage. And we have another oscillator on here called the frame oscillator. That's this thing, the 50 hertz, okay? And this is driving another transformer, but now at 50 hertz, not at that frequency, 15.625. And this one then is driving the scan. So this is the frame scan, this is the line scan. Frame. So basically all that put together is how a colour or a monochrome CRT television actually works, yeah? I'm interested to hear comments below if I explained that well enough. There's quite a bit to take in, but I think I hopefully did it. So first we have a tuner. So the tuner is attached to the antenna, and this tunes in the TV station. Once we have a signal, the signal is split 3 ways. So within the signal we will find video, audio, and synchronization, sync pulses, okay? So these are now sent 3 different ways. We have here our CRT, we'll draw this. We have the final anode, this is your 25 kV high tension, okay? And in here we have the 3 cathodes with the heating elements, okay? We have the 3 control grids, 1 for each colour, okay? We have the focusing anode. This has around 5 kV on it, okay? And we have the accelerating anode, which has a similar voltage. Accelerating anode, this is focus. This is the accelerating anode, okay? This is the final anode. So we need to generate all the signals for this. Now let's look what happens to the signals we have coming in. So the audio goes into the audio amplifier. Audio amp. And this goes to the speaker. Okay, obviously. The video comes out. And this drives these 3 control grids. So the video coming out, we have red, green and blue, 3 signals. These control grids are driven by transistors. I'll just draw them roughly. So we have and try not to mess this up so I don't have to do it again. Okay. We have 3 video output transistors, okay? And these are driven from the signal. So let's see if we can draw it. Red, green, blue, okay? And the red signal will drive this one. Obviously not directly, there's a bit of circuit in between, okay? Green will drive this one. And the blue will drive the other one. So those are our video signals driving the control grids. We now have to scan the image. So coming out of here, we have 2 synchronizing pulses. We have line sync and we have frame sync. Or if you like, vertical sync, horizontal sync, which is line. Call them whichever you wish, okay? So the vertical sync goes into the frame oscillator, or vertical oscillator, which is called the frame, okay? This runs at 50 Hertz. This drives via the frame output transistor. Again, some more circuitry is involved. Look, I've drawn it messed up already, okay? This drives the frame output transformer. So we have a transformer here, FOPT, frame output transformer. And this is driving the coils around the cathode ray tube that gives the vertical deflection. So we'll put a coil here, and this is driven by our frame output transformer. That gives the vertical scan 50 times a second. Now we have the line oscillator, or horizontal, okay? Horizontal or line. And we have the line sync, or horizontal sync signal. So that synchronizes this, and this again drives a transistor. This is called the line output transistor, okay? And this, I'm sure I've drawn that on the wrong, somebody's going to tell me I've messed this completely up, so I'm going to do this one right. Okay, so this drives the line output transformer. Okay, imagine that's like that, guys. This is just a rough diagram, okay? Ground. The line output transformer, LOPT. This again drives the scan coils around the CRT. So we have a winding that's driving the scan coils. Okay, we'll put it in purple, why not? So we have this one. This is driving the scan coils that drive the horizontal scan. And also on here, we have another winding. Another secondary winding. This generates the HT. So the HT is the 25 kV to the final anode of the tube. It's also from the HT derives the 5 kV focus. So this is HT and focus. And other high voltages that are required on the accelerating anode and such like are from here, okay? This oscillator runs at 15.625 kilohertz. So that is basically your TV set. Line output transistor, frame, output, transistor. Now you need also to power all this circuitry, and this is not powered directly from the mains. In older TVs you would also have a power supply, an early type of switch mode power supply in many cases that would power this circuitry. But in later TVs they realised that they didn't have to have a separate power supply because they could put another secondary on the line output transformer, or more than one other secondary. Okay, so these are all on the same transformer, and this one generates all the supply to the circuitry. We'll call it the auxiliary supply. So this basically generates the supply to the frame output, to the oscillators and everything else. So when the TV first starts up, there's a startup circuit that gets this running, and once this is running, this generates its own power to everything else. There was a myth when this first came out in the 80s that you could plug the TV in, and once it started you could unplug it from the mains. It would keep on running. Of course it wouldn't. Okay, this circuit, which basically combines or synchronizes the line oscillator, the high tension generation, the line scan generation and all the auxiliary supplies, has a name, and it's called Cyclops. And this stands for synchronous converter, which is the power supply part, synchronous converter and line output stage. Okay, now we know what we have. Just before we look at our TV to see if it's working, is it faulty? I don't know, I haven't plugged this in yet. Let's just discuss a few things about what usually goes wrong with these TVs. So, as in most cases, whatever is doing the most work usually fails the most often. So, apart from the usual thing with electrolytic capacitors, the common things to fail are the line output transistor. This is doing a great deal of work. Any sort of short circuit on one of the outputs will stop this from working and usually blow the transistor as well, and maybe the driver stage between the oscillator and the transistor. So line output transistor is a very common failure. The line output transformer itself tends to arc over internally and fail. This is because of the very high voltages here, 25,000 volts. Okay, so those fail. Frame output fails less often, but again it's doing work so it can. Cathode ray tubes themselves fail. What normally happens with these, apart from being physically broken, is that the cathodes, which are emitting the electrons over age, will wear out. So gradually the emission of electrons gets less and less, and you find certain colours are not bright, or you lose a certain colour. Another reasonably common one is failure in the output stage, the video output. So it's really the output stages that tend to go wrong. If you lose one of these stages, faulty transistor or such like, then you will lose a colour or more than one colour. If you lose the frame output, you'll lose the vertical scan, so you end up with a horizontal line across the screen. Okay, now you may think that if you lose the line output, you'll end up with a vertical line on the screen, but in fact you won't, because if the line output goes, the HT goes. You've got no HT on the screen, on the tube, so you have no picture at all. Those are common failures. Obviously, I think you can see from here, if you have a picture that's rolling vertically or sideways, if you lose the synchronization, the problem is in this synchronizing circuit. Tuners failing will give you no picture, or rather just noise on the screen, no signal. But that is pretty much a good idea of what goes wrong. And don't, of course, forget the audio amplifier. Audio output transistors can fail. Okay, so now we have some idea what to look at on our TV. Let's power it up and let's see what it does or doesn't do. So let's see what's happening with this. You can just about see my power supply there above the top of the TV, okay? So I have this set, well, we'll just put it a bit more accurately. I have this set to 12 volts, okay? I've switched the TV on with the button and I've switched it to radio at the moment, so it's just on radio. I've reconnected the speaker, I've just extended the wire a little bit to make it a bit easier. So we'll connect this to the power supply. I've also set the power supply to a maximum of 2 amps. I've also just noted actually on the TV it is not 12 volts, it's 13.8 volts, so we'll give it a little bit more power. Okay. Let's see what happens. So this is set to radio. Switch on and see what it does. Well, it draws a little bit of current. Okay, as you'd expect on the radio, I don't hear anything. Is this the volume? Let's see. Yeah, tuning and volume. So it's drawing a bit of power, but I don't actually hear anything. Okay, so that's the first problem with this. It seems the radio isn't working. This is the on-off button. Okay, off, on. So it's drawing definitely a little bit of power. These are your AM, FM and such like. Let me see. Well, it looks like the buttons are all jammed in actually. These are supposed to like kind of like switch between one and the other. I'm not sure they are doing. Okay. So there's the first problem. The radio isn't working. So I guess we have to fix this one first and then look at the TV afterwards. I suppose, in fairness, we could just try the TV instead first. Okay, so we'll switch the power off. This is now on TV. Let's see what it does. If it's going to do anything more spectacular, it will do it now, I am sure. Well, it's just drawing more current, okay? Nothing spectacular happened. I don't see anything on the screen. Nothing lit up. So it doesn't seem to do anything in either mode. Okay, you can just see the top corner there. Nothing happening, nothing lit up. Okay. Oh, something is lit up. Did you see it on the screen there? Watch. Yeah, there, a little flash, yeah? That tells me there's lots of high voltages in here. That's the first thing for sure. So it's kind of scanning on the TV, but shutting down by the looks of it. And the radio isn't working. Let's have a look at the radio first. Let's see if we can figure that one out. I've tried Googling for this TV. So this is a Sonico. Okay, there is no model number on it. There's nothing underneath it to say anything. Okay, on the top there's nothing, there's no model number, just tells us the controls. I have no idea what VLVH is. I have figured out these switches are not ganged together, so they do operate. This one is AM FM. This one is the VHF UHF for the TV tuner, and this I have absolutely no idea. Okay. VLVH. Backplate, no model number, no information. So I've tried Google for Sonico 6-inch multi-color TV, which is what it says on the top cover basically. That thing, multi 6-inch color TV monitor, and I'm not finding anything. I'm finding mainly links to Sonic the Hedgehog, yeah, which in Spanish apparently is Sonico. So if any of you guys know more about this, what it actually is, do we have any information out there about it, let me know please, comments below. But I have thought, well, there's no audio, so probably the first thing to test is whether there's any power on the audio amplifier. Now, I think the audio amplifier is on this board for the sole reason that the wires go this way, okay? The speaker wires. But when I just looped it, I'm going to show you this now. I didn't just do it, by the way, that fell over. The black wire is broken off, so I actually only have one wire. So the first thing I need to do is figure out where this goes. The green wire quite clearly goes down here. And I think this might be the headphone socket. Yeah, earphone external speaker, this one. So I would imagine that the black wire also goes down here somewhere. This board looks like it'll come out fairly easily as well, so perhaps we can have a look and figure this one out. I don't think it'll be too difficult, so let's try. Well, I have the board loose, it just clipped out of the little plastic holders. What we do have is a lot of wires holding this in place. I see now why somebody's actually unsoldered these wires at some point to get this board off. There's also one at the back which is holding it, which we need to unsolder as well. And then hopefully we can lie this board flat and we can actually have a look. It's quite clear this thing was effectively put together, the circuit boards, and all these wires were soldered on by the looks of it. Okay, so let's desolder a few wires and have a look. The one that's preventing me from moving this board first is this red one here, this short one, okay? So that's the first one we'll have to desolder. So can we get in at this now? Well, it's these three across the top, okay? So these have been unsoldered before. Let's just disconnect them. Okay. And now maybe we can get into this. I'm hoping so. Well, it goes to the CRT base, so this needs to come off. Now, there may have been some high voltage in this, but it's been switched off for some time now, so I'm thinking it's okay. We'll find out, okay? If you're going to do this, do it with one hand, not both. Just pull the base off the CRT, there we go. That gives us a little bit more room, I think. And I can kind of see down here now, not very well, but I can see. I don't know how easy this is going to be for you guys to see what I'm doing here. I can see the green wire, which is kind of like wrapped over these black ones. I can see where it goes to. And then the black wire obviously goes here as well. I'm fairly sure these will just connect across the headphone socket basically. So if we plug a jack plug in here, we should be able to find, hopefully the end pin will go to the green, and wherever the other part of the jack plug goes, I'm guessing that is where the black wire goes. This is really quite hard to record, guys, because the angle I have it at and how difficult it is to get this board off. But I'm hoping I don't actually need to. So what I've done is I've plugged a little lead into the jack socket. This is a stereo one, this will be mono, I am sure, but this will be effectively the ground and this will be the signal. To figure out where these wires go, we'll go to the ground on here, and this is probably ground here, I would imagine. Yeah, it's ground here. And then the end connector, the audio, that one. Well, that's where the green wire is, and it doesn't go there. Oh, it goes here, it goes to the one next to the green wire. Now that's probably because this connector has a switch in. So when you push this lead in, the end, the audio will go to this pin. That's not connected to the green one. But I imagine when I unplug this, this and this point will connect to each other. So let's try it. So we have it disconnected, and now I think we'll find this end pin, which is where the audio was, will also go to the green. Yes. So the speaker is connected to the right place. It's just when you plug this in, it disconnects the speaker. That's normal enough. So the black wire simply goes here. Okay, so I've soldered the black wire back on. Now let's see if we have any audio. Maybe the radio is actually working. I've connected the wire then to the speaker. It's set to radio. Let's see if this actually works now. Well, we have sound. Oh, and we have radio. Okay, so radio is working. Okay, so let's see if the TV seems to be running again. This is now set to TV. But I'm not getting this flash on the screen anymore. I am getting sound or hissing. Oh, and we have a picture. Yeah. Obviously there's no TV channels broadcasting, but I think if I connect a complete video source to this, we might be able to get something recognisable out of it. Let's try it. Okay, so basically this is functioning. It really needs setting up properly. You see it's having a bit of trouble with the vertical hold. There it's scrolling. It's having a little bit of trouble with the line sync as well at the top. You can see the picture sometimes like stretches over. There's a whole load of adjustments on here, and probably one of these is the line sync, but I have no information with this, so I think we've done plenty on this video. This is also, by the way, like a wide screen image. It's not 4:3, it's 16:9, and that may also be causing some problems with the sync. So, does anybody know what this model is? Does anybody have any information on it? If so, I'd like to just play around with the settings a little bit. The other thing I suspect with this is probably just old capacitors, because the thing is basically functioning pretty well. I'd like to find a proper 4:3 video source for it. I think that might help it a little bit as well. But yeah, it's running, that's the thing. I've also realised why I had no sound on this. I had the wrong lead plugged in basically. So we do have audio there. Okay, you can see it. That's the problem with the sync I was mentioning, that on fast moving images, losing sync, almost certainly bad capacitors. So, I can try to adjust that a little bit. Yep, there we go. And this is this line tearing I'm talking about at the top of the image. We have a little bit as well. That's a problem with the line sync circuit slightly. Okay. But although this wants a little bit more work, it is basically functioning. The flicker, by the way, is being picked up by the camera. It's not on the screen. So there we are, partially repaired. I think to go further with this, I could really do with finding the user manual. There's a lot of adjustments on this which are not marked. Yeah, I'm just looking, they're not marked on the board. I don't have a user manual, or rather a repair manual for this. Maybe somebody can identify this for me, and then we can have a play with that. It's quite possible, because of the age, that just some things have gone out of tolerance, and a few adjustments might get the sync working properly, the horizontal sync. The vertical sync I already knew where to adjust, that was that one. I have that adjusted correctly, I believe. But before we do that, I'm just interested to know what you guys think of this sort of repair work. I mean, are you interested in this sort of equipment? Yeah, it's old, but I think this is quite useful, particularly if you're working on and repairing old vintage home computers and games consoles that had an RF output. You can connect them to this, or just put the cable up to the aerial basically and tune them in, test if that's working. Sure, you could do it with a modern TV, but this is quite small, although a little bit deep to put on the desk, but I quite like this sort of equipment. However, it's really down to you guys if you want to see more of this sort of repair work. I can also do older if you want. I can do vacuum tube repair. I was trained on that in the early 80s. It's a long time since I've done it, but I'm sure I would refresh my mind pretty quickly if we want to look at that sort of stuff. So let me know what you'd like to see on the channel is the basic question really in the comments below. Hope you enjoyed that. If we do bring this out again, I think the first thing I will do is replace a lot of the capacitors, which will mean removing these boards, but I think that will also help a lot with it. It's just a big job, because basically the only way to do it is to unsolder all the wires that are attached to it, pretty much. Make a note of where they go, replace all the capacitors and stick them back on again. It's not easy to work on this sort of stuff, that is for sure. I hope you enjoyed that anyway. That was a quick beginner's 101 in cathode ray tube TV repair. At least, if anything, you've come away with an understanding of how these things work. Interesting again, I find something at the car boot cell that basically works, yeah, but it was an interesting tool to learn from. Okay, so regardless of whether you're really interested in this sort of stuff or not, I hope to see you again soon on another Learning Electronics Repair video, where no doubt we'll be doing something completely different. Okay guys, so until next time, adios amigos.